All right, guys. Today in class we talked about factoring linear expressions, which is going to be the exact opposite of what we did yesterday when we expanded linear expressions. So yesterday we used the distributive property, and we said we took this factor that was on the outside and we multiplied it to everything that was on the inside. Okay, so we said A times B gave us AB, A times C gave us AC. Okay, today what we're going to do is we're going to work backwards. We're going to start with this side. We're going to start with our expanded expression, and we're going to factor it, which just means we're going to find this factor that goes on the outside of the parentheses, and then we're going to find the terms that go on the inside. So steps to factoring. First thing we're going to do is we're going to find the greatest common factor of both numbers in the expression. Okay, then we're going to put that greatest common factor on the outside of our parentheses. Then we're going to divide each term in the expression by the greatest common factor, and you can always expand out your expression to check your answer. Okay, so let's take a look at two different examples. The first one we've got here is 15a plus 10. First thing we're going to do is find our greatest common factor. Now, the way that we learned to find greatest common factor was by using prime factorization, and we're going to use that same method today. We're going to put 15 and 10 at the top of our factor trees, and then we're going to break both of those down. I know that 3 times 5 would give me 15. They're both prime, okay? So my prime factorization for 15 is 3 times 5. We're going to do the same thing for 10. I know I can multiply 2 times 5 to get 10. 2 is prime, and 5 is prime. So our prime factorization for 10 is 2 times 5. So we're going to figure out what they share from our prime factorizations. They don't share a 3, they don't share a 2. However, they do share a 5. That's the only number that they share. And since they only share a 5, the greatest common factor is 5. Okay, so since we found the greatest common factor was 5, from our original expression, 15a plus 10, we're going to take our 5 and we're going to put it on the outside of the parentheses. Now, to get our inside pieces, what we're going to do is we're going to divide each term by 5. So 15a divided by 5 leaves us with 3a. Okay, now we're going to look at this as a separate term. This is a positive 10. Positive 10 divided by positive 5 is a positive or plus 2. So our factored expression would be 5 parentheses 3a plus 2. Okay, now let's look at our second example down here. It is a little bit different because we've got some negative signs in there as well. So something you need to pay attention to when you're factoring, just like when you were expanding, is where there are negative signs at in your problem. So if you notice that both terms are negative, so I have a negative 6y and I have a negative 24, they have in common a negative sign. So we're going to find the greatest common factor, but it is going to be a negative because they both share that negative sign. Now, if only one of them had a negative sign, your greatest common factor wouldn't be negative because they don't share it. However, in this example, they are both negative. So they have that in common. It's part of the greatest common factor. All right, so first off, let's factor them out. We're going to, like I said, they share a negative, so I know that my greatest common factor is also going to be negative. Okay, so let's break down our numbers. I'm going to start with 6, and I can multiply 2 times 3. 2 and 3 are both prime, so my prime factorization for 6 is 2 times 3. Now, if we do 24, we could break it down lots of ways. I'm going to break it down to 6 times 4. Neither one of those are prime, so we got to keep going. For 6, we can do 3 times 2. And for 3 and 2 are both prime. Okay, so we're done there. For 4, we can do 2 times 2, and both of those are prime as well. Okay, so that makes our prime factorization for 24 2 times 2 times 2 times 3. Now we need to see what they share. We see that they share a 2, and we see that they share a 3. However, they don't share any of the other 2's. Okay, so our greatest common factor is going to be 2 times 3, which is 6. However, we know they share a negative, so our greatest common factor is going to be a negative 6. So if we have our original expression, negative 6y plus negative 24, our greatest common factor is a negative 6. So we're pulling that out of our expression. To get our inside pieces, what we're going to do is we're going to divide. So we have negative 6y divided by negative 6. Negative 6y divided by negative 6 is just positive 1y, and we just write that as a y because we know a negative divided by a negative is a positive. So we're going to do the same thing with 24. We have negative 24 divided by negative 6. A negative 24 divided by a negative 6 gives us a positive 4. So our factored expression is negative 6 parentheses y plus 4.